Example 4, determining irrational zeros. Given the factor x plus 4, what are the zeros for the polynomial functions of f? Well, let's start with reminding ourselves, when we talk about zeros, we could look at the graph, and when I look at the graph here, I should be able to see any zeros that occur. And in this case, I have x cubed minus 19x minus 12. I look at the picture, there are 3 zeros. Now, one of these zeros is a great value. If you go to Menu, Analyze Graph, and choose 0, or if you're using Desmos, you just look where you click where it crosses, and you see -4 is a great answer. However, these other values are irrational. These values are not on our list from earlier. We wouldn't have a list like that. Factors of 12 would be, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 4, and plus or minus 6 and 12 finally. That's not one of those values. So that's irrational, and if you check, we have another value. It's also going to be irrational. These values are not rational. So how do we find the irrational? Well, here's what we do. We first start with, given this factor, you could find it 0 by saying inside lies. So if you set it equal to 0, you would subtract the 4, and we discovered that this creates the 0 of -4. And now I'm going to use our synthetic division we learned in lesson 2.3 to solve for my other zeros. Now for the first step in synthetic was you solve for x equals what x equals, which in this case is -4. The second step is you come over to your dividend and you check for any missing powers, which in this case I don't have a squared, so I want to include a 0x squared. And our third step has to do with our answer. If there's a number in front of a leading term in the divisor, you divide the quotient by it, but we don't have one, so we don't have to worry about step 3. So let's write these out. I have 1x cubed followed by 0x squared minus 19 minus 12. When I try to solve this, the 1 drops, and so I have 1 times -4, and that'll be a -4 there. I combine my like terms. 0, -4 is -4. Multiply now. -4 times -4 is a positive 16. Positive 16 and -19 make a -3 when you combine your like terms. And then I multiply again, and I get a positive 12. This gives a remainder of 0, which is good because the remainder should be the y value, the f's value at that spot. So we should get 0. See how the y is 0? That's what it's supposed to be. That means my other factors come from the equation. Since this was a cube, this is 1x squared minus 4x minus 3. That's where my other two irrational factors come from. Now typically, when you see a trinomial, I would say use x method. But x method only works for rational factors, and we'll determine, as we've already determined, there is nothing that's rational that'll work here. Some people are going to look at this and say, wait a minute, factors of -3 that add to -4, shouldn't they come from 3 and 1? Here's your problem. To get -4, these would both have to be negative, and two negatives when you multiply give you positive 3. So these do not work. For that reason, there's no rational factors. They're going to be irrational. So how do we find our irrational? Well, one method you've learned in previous courses is your quadratic formula. Whoops, formula, which is that x equals -b plus or minus b squared minus 4ac all over 2a. And so you could solve for your x's right away like that. Now, Alex isn't going to work that way. It's not going to want our answers in this form, so there's two things we can do. So first, let's solve it using quadratic formula. We would say that the zeros, this would find our zeros, will be -b. So I have a negative of a -4. Let me erase this here. -4, that was ugly. This is our a for the record, this is our b, this is our c. So a negative of a -4 plus or minus square root of -4 squared minus 4 times our 1 times our c, which is -3. And all this is going to be divided by 2 times 1. Now when we simplify, negative of -4 is +4 plus or minus square root. That's going to be 16. -4 times -4 is 16. minus, there's two negatives here, that'll be actually a plus. 4 times 3 is 28, all divided by 2. 16 plus 28 is 44. And I'm checking real quick, make sure, -4 times A times C. Okay, making sure I have our values on there correctly. So when I add these, I get 44. So 4 plus or minus square root, and 44 is, hang on one second, I really feel like I got something off here, because I know what number I'm looking for and I'm not getting it here. 16 minus 4 times 1 is -4 times 3 is plus 12. There we go. That's supposed to be a 12. Bad math. Which would give us 28. There we go. Now we're on. All over 2. And I'm going to simplify this and divide here. Square root of 28 is the same thing as square root of 4 times the square root of 7. And so I have 4 plus or minus, I'm going to go 4 divided by 2. And then over here, square root 4 times square root 7 divided by 2. And that will equal, when I simplify, 2 plus or minus the square root of 4 right here is 2. Those get canceled, and plus 7. So those are our zeros. So if it wants to know what are the zeros, our answers would be x equals this 0 of -4, and then 2 plus or minus square root 7. Now if you were working your Alex is a little different, that they're going to actually just want it as in factored form. And so in factored form, I'll write that right here, factored form, you're going to have the -4. You take your zeros and basically we make them lie as we put them in parentheses. So we're going to take all these 3 zeros and say we would have f equals x plus 4 times x, got to make the 2 lie, minus 2, and I'll take the positive and make it lie, minus square root of 7, times x, again we make the 2 lie, minus 2, this time I'm going to take the negative square root, which will become a positive square root of 7. That would be my factored form, and that's on for Alex's homework. You'll see problems like that. I think it's number 5. You'll see it's somewhat in this form.